Okay, on the second part of this video, I'm going to go over just a few chain rule problems that involve trig. There's two different ways that the chain rule sometimes can get involved with a trig function. One is if you have the trig function of another function. And this is the one that we look at most commonly because we typically talk about that the derivative of sine of u is cosine of u times the derivative of u with respect to x. So the idea of that is that the sine is, there is a sine of a function of the variable x. So like here with a u of 2x, essentially, when I take the derivative of the sine of that u, I'm going to get the cosine of that u, so the cosine of the same argument, 2x, times the derivative of that 2x, which is the 2. And then we may typically rearrange that nicely, constant factors up front seem to look prettier. Using some grouping symbols around the argument, around the u aspect of the trig function kind of helps keep everything clean. So we see something like that. Yeah. Mix that in with other constant factors, and you might get some other multiplication things going on. So paying attention, first of all, that this is a cosine function. So when I take the derivative, I will be getting a negative sign. And remember, if you need to, there's a little chain up there, derivative of cosine, one step down is negative sign. So my derivative is, I'm going to keep the 3, or you can kind of carry the 3 along for the ride. Cosine's derivative of is negative sine of 4x, and then times the derivative of the 4x with 4. When we clean that up in a little bit of a nicer package, we can look at that as a negative 12 sine 4x. And honestly, I will oftentimes sort of derive and combine at the same time. It's good to slow yourself down. Okay? Nothing wrong with that, especially when you're dealing with some new rules like the sine and cosine are, and working with those new functions mixed in here with the chains. If you notice, I've thrown some other fun guys in here, like number 14. Scooch this up for a second. It's got a natural log in there. So the main function is the tangent. So when I take the derivative, and if you want to do this, you can sort of think about the u, that the u is the natural log of x. So that the derivative of the natural log, hopefully we remember, is 1 over x. So when I take the derivative of the whole thing, the derivative of the tangent of u is the secant squared of the u times the du. Same kind of thing on 15. If u is e to the x, then the derivative of u, hopefully remember, is e to the x. So the derivative of the whole thing would be the cosine of e to the x times another e to the x. Okay, I'll leave 12 and 13 for you to do. And if you want to rewind back and look at how 14 and 15 worked out, you can do that. Another kind of chain rule problem that can involve trig is when the trig function is the inside part. The trig function is actually more like the u. And this is kind of our more typical chain rule kind of problems where we're used to seeing something inside a parentheses. And that inside stuff just happens to be trig this time. This sometimes tends to be harder to kind of go around. When I set my derivative up and I think about how I take the derivative of something squared by bringing that 2 down. Sometimes it's hard not to change the inside, because when you go to the derivative step, you're going to get that. Now let me just take a step back here for a second. Now I'm really rethinking how I talked about that. I think it would be helpful if I had done one like this first. Remember when we have something like this, right? And I take the derivative, that 5 comes down, Mr. Inside stays the same. We power rule, and then derivative of the inside. The exact same thing is happening with a trig function on the inside. There's me writing in that yellow again. Why I keep hitting that yellow? I want purple. So if I put something like a tangent function to the 5th power, the 5 comes down in front, just like on the other example, and comes down to a 4. And then I take this guy and go, well, what's his derivative? Tangent's derivative is secant squared of x. Oops. I just got extra kabujis there. So in this case, you end up with more trig than you started with, and that kind of always seems weird. It's not like one trig changing into another. It's like you've got some trig there, and there's some stuff happening, and then you got more trig floating around in the problem. Excuse me. The other thing that can compound, this, do a quick pluggy here real quick, so die before we finish. The other thing that can compound the difficulty level of these is the way they're written. Okay? They're typically not written with parentheses, or it's an acceptable notation to not use parentheses, and so on a problem like number 18, sine of x quantity cubed, the parentheses are not there. The 3 is written next to that sign, but your interpretation is to be that this is a quantity of sine that is all being cubed. Rewriting it with parentheses definitely makes the chain rule aspect of it a little bit more comfortable. And so 17, 19, 20, and 21, I'd say go ahead and give those a try and check some answers, look at my steps. And that's a good kind of 5-minute attack on chain rule in trig function derivatives.